Hey guys, so a couple days ago we learned how to write linear equations, then we learned how to graph linear equations. Today we're going to review how to solve linear equations, which is something that you've done before. These ones might just be a little bit more complicated than the ones you're used to seeing. We're also going to learn how to verify your solutions, which is just a way of checking to make sure that you're right. So this is lesson 5.4, solving linear equations. And when we say to solve a linear equation, what we mean is to determine the value of an unknown variable. So essentially your x or y when you're given either the x or y. To do this, we have to isolate the variable using opposite operations. So when we say isolate a variable, we mean we move everything other than that variable to the other side of the equal sign. Get the variable by itself. When we're moving things to the other side of the equal sign, we always start with whatever is furthest from the variable and then get closer to it. If the variable is part of a fraction, the denominator of the fraction must be the part that moves, even if that is the variable. If that's the case, the variable would have to move to the other side. And as I'm sure you guys all know, our opposite operations, multiplication and division are opposite, so is subtraction and addition, so is taking the square root of something and squaring something. So let's get into some examples here. Okay, for example number 1, we're going to do 13 equals 4 over 2x minus 3. So we need to get our x by itself. When we move things to the other side, we start with whatever's furthest from the x. So we're going to start with the minus 3. Because it is minus 3, the opposite of that is plus 3. So we'll use that opposite operation to cancel it out on this side. What we do to one side, we must do to the other. So we will add 3 to the other side. That leaves us with 16 equals 4 over 2x. And now we've got a fraction here, which the variable is a part of. As I said, the denominator, so the bottom has to be the thing that moves. The opposite of division is multiplication, so we will multiply by 2x, which will cancel out, which means we also multiply the other side by 2x. So that leaves us with 2x times 16 equals 4. Now we're still on this side trying to get everything away from the x. So you can either multiply the 2 and the 16 together and then move them, or move them one at a time, which is what I'm going to do. So I'm going to divide by the 16 to move it to the other side. That leaves me with 2x equals 1/4 or 0.25. And then to move the 2 away from the x, I, of course, divide by 2, which leaves me with a final value of x equals 0.125. Let's try a second example. So 16 equals 5 minus 3x over 2. This time, once again, we have to start by moving whatever is already furthest from the x. So we're going to start by moving the 5. Even though subtraction is happening here, we always look in front of the term that we're moving to see if it needs to be added or subtracted. So this is a positive 5. That means we have to subtract to cancel it out and move it to the other side. So we subtract on the other side as well. 16 minus 5 gives us 11, and we are left with negative 3x over 2 on the other side. It is important to note that signs always go with the term behind them. So when I move this 5, this minus sign becomes a negative sign. It still goes with this fraction that's behind it. So that's why we have negative 3x over 2. Then, of course, I have to move the denominator, so I multiply by 2, which leaves me with 22 equals negative 3x. And then, of course, we divide by negative 3. which leaves me with negative 7.3 repeating as my x value. The next thing I want to look at is how to verify these answers. So how to double check that they're correct. Okay, so when we're verifying a solution, all we're going to do is take our solution and plug it into the original equation that we started off with. We then solve the right side and the left side separately. So we're not going to be moving anything to the other side of the equal sign. There won't be any opposite operations. Our solution is going to be correct if, in the end, the left side equals the right side. So let's take a look at what this would look like. So we just had, for example, number 2, we had 16 equals 5 minus 3x over 2. And we ended up with the solution of x equals negative 7.3. That was the one that we just solved at the bottom there. And so all we're going to do is we're going to take this solution and plug it in where the x is in our equation. So we end up with 16 equals 5 minus 3, and instead of 3 times x, it's 3 times negative 7.3 repeating over 2. And so the next thing that we're going to do is figure out what negative 3 times negative 7.3 repeating is. So negative 3 times negative 7, a whole bunch of 3's. That gives us 21.9 repeating. You'll notice that I did negative 3 times negative 7.3. and then ended up with a positive sign here. Again, that's because signs always go with the term that's behind them. Anyway, that's still over 2. So then we have 16 is 5 plus, and we'll do 21.9 repeating over 2, which gives us 11. And then 16 equals 5 plus 11, which is 16. So our left side equals our right side, which means that our solution of negative 7.3 repeating was correct. Okay, so this verification process is really useful. You can use it in a test or quiz anytime that you have found a solution to double check that you're right. The very last thing I want to touch on just briefly is something called equivalent expressions. These are expressions that are related because every term has been multiplied by the same number. So for example, if I had the expression x plus 2y equals 3, that is equivalent to 2x plus 4y equals 6. Because essentially all I've done is taken every single term from the first equation, multiplied them each by 2 to get every term in the second equation. Okay, that's it for today's lesson. Let me know if you have any questions.